Hello and welcome into video number 2 for lesson 1. This is going to be the sample problems for our fraction problems, for our union and intersection, our interval notation, and a couple absolute value problems to end it. So let me share the document camera here for you guys. All right, so the first example we have is using our properties of fractions. And the first one we have is 2/3 minus 5/8. And so if you remember, when we did these, if we don't have the same denominator, we can use this shortcut method I showed you. But the key is what? I have to multiply these two first. So 2 times 8. And then because I have a minus sign here, that goes next. And that's why the order is important. Because if I reverse these, the order of subtraction is not correct. Then I multiply this way 3 times 5. And then I multiply the denominators 3 times 8. So now simplify 2 times 8 is 16. Minus 3 times 5 is 15. And 3 times 8 is 24. Simplify one more time. 16 minus 15 is 1 over 24. What I would say too, and I should have mentioned before I started this problem, if you think you kind of understand the concepts and you want to try it, as soon as I put the problem up, just hit pause on the video, try to work it out. Then you can like double time the video or scroll ahead a little bit and see if you have the answer correct. If not, then you can see how to work it out or maybe where you went a little bit sideways. But for that example, our answer should be 1 over 24. And that's going to be the process for any of these fractions that don't have the same denominator. All right, what if I have 4 plus 1/3 times 1 minus 3/4? So with this one, we're going to use our order of operations, PEMDAS, right? So we're going to do what's inside the parentheses first. So for this one, 4 plus 1/3, I can think of this like 4 over 1. So when I do my cross multiply, I have 4 times 3 is 12, plus 1 times 1 over 1 times 3 is 3. So 13 over 3 is this first fraction. The first parentheses, if I simplify it, it's 13 over 3. Then this one, again, if you want to think of 1 over 1, 1 times 4 is 4 minus 1 times 3 is 3 all over 1 times 4 is 4. So this is 4 minus 3 is 1 over 4. And now I have what? I have two fractions that I'm multiplying. I love to see that because that's our easiest fraction math that we can do. So multiply across. 13 times 1 is 13. 3 times 4 is 12. And that's it. I can't simplify. I can't take a common factor out of any of these. So your answer for this one is just 13 over 12. Our third example, again, fraction math. We're going to be doing now what's called a compound fraction. So that's just a fraction that has fractions. So like a real messy fraction, really. So we have 3/7 plus 1/3 divided by 1 over 21 plus 4 over 28. So what I'm going to do here is combine the numerators, combine the denominators, and then my division, which is what? Keep, change, flip, because it's this fraction divided by whatever this fraction ends up. So let's deal with the numerator first. So by my shortcut method, I have 3 times 3 is 9, plus 7 times 1 is 7 over 7 times 3 is 21. Simplify this. 9 plus 7 is 16 over 21. All right, let's work on the bottom. Now, I could do cross multiplication method right away, but this 4 over 28, I can make my life easier, right? If I can simplify these fractions, then I'm not dealing with such big numbers. So I can actually divide the top and bottom both by 4. So 4 divided by 4 is 1. 28 divided by 4 is 7. So 4 over 28, I can really reduce to 1 over 7. And now it makes my life a little bit easier. So I have what? 1 times 7 is 7, plus 21 times 1 is 21, over 21 times 7, which is what? 147. So some messy numbers there. So add these two, 7 and 21 is 28, over 147. So now we can do what? Keep, change, flip. So keep the top one. And this is 6. So if we want to think about this, this is really what? 16 over 21 divided by 28 over 147. So keep, change, flip. Change this to multiply, flip this guy. So 147 over 28. And we know this one, 147, we got from what? 21 times 7. So this is really 21 times 7, which means the 21 down here will cancel with the 21 up there. And now again, this 7 cancels, gives me 1. Well, it cancels with the 28, gives me 4. So it makes my life easier when I can break these numbers down, and I can actually do it again, right? Because the 4 cancels with 16, and all I have left now is 4 times 1 in the top, which is 4, and then 1 times 1 in the bottom, which is 1. So the answer to this is 4. So a lot of you guys like to tell me the answer is 4 over 1. Yeah, it is, but that's not simplified all the way. Tell me that the answer is 4. Do not leave it as, oh, the answer is 4 over 1. So the answer is 4. Simplify it as much as you can. So that's how we handle these compound fractions. Combine the numerator, combine the denominator, and then at the end, keep, change, flip. All right, let's look at our union and intersection problems. So let's say set A is the numbers 1, 2, 3, 4, 5, and it has the braces, so it's only those numbers, not anything in between, not 4.5, not 2.3, no, just those numbers. And then B is 1, 3, and 5. So if first I want A union B, that means what? It's all of the numbers. So all the numbers from A, so 1, 2, 3, 4, 5, and then all the numbers from B, 1, 3, and 5, which are already included. So the answer for A union B would just be the set 1, 2, 3, 4, 5. And A intersect B, well, this is overlap, this is and. Which number is in A and in B? Well, is 1 in A and B? Yes, it is. Is 2 in A and B? No. Is 3 in A and B? Yes, it is. Is 4 in A and B? No. Is 5 in A and B? Yes, it is. So we get just the set 1, 3, and 5. So that's how we do union intersection when we have just sets of numbers, not intervals. Because let's look at how we do an interval. So let's say I want -3 to 2, both of them have parentheses, intersect 0 to 5, also both of these have parentheses. So if you remember from video 1, to solve these, we're going to do what? We're going to draw a number line, and because it's intersection, we want to find the overlap. It's a lot easier to do visually with a number line than trying to do this in our head or some other method. So for the first one, -3 to 2, well, because they have parentheses, that means what? Open circle. They're not included. So I get that picture there, -3 to 2, open circle on both ends. And then 0 to 5, well, 0 is between -3 and 2. 5 is out here. Again, because they both have parentheses, they're going to get an open circle. So I get that picture. Now, because I'm looking for intersection, I want the overlap. So the overlap is happening where? It's happening right here. This is where my overlap is, all of that section there. So it's going from 0 to 2 is the overlap. But now I need to decide, okay, does this get parentheses or does this get brackets? Well, because I have an open circle here, remember it's and. It has to be in both of them. So an open circle wrecks everything. So because I have an open circle here, it means 0 is not included because it's not in both of them. Therefore, it gets a parenthesis. And similarly for the 2, there's an open circle here. So even though 2 is included up here, because it's not included down here, I can't include it in the intersection. Therefore, it gets a parenthesis. So my answer for that one, for -3, 2, intersect 0 to 5, parentheses on all of them, would be 0 to 2 with parentheses on my answer. Now let's look at, change it up a little bit, -3 to 2. Now they both have brackets, intersect, 0 has a parenthesis, but 5 has a bracket. Again, intersection, overlap, draw the picture. So we have -3 to 2, but because it's bracket, they both now get a closed circle. So we get that picture there. That's why that differs from up here. Here, because of the parentheses, it got open circles. Now, because of the brackets, they get closed circle. And then 0 to 5, well, 0 still has parentheses, so that's an open circle. But 5 has a bracket, so that's included, so it gets a closed circle. So we get that line. Intersection overlap, well, the overlap is still here from 0 to 2. And now let's check. Does it get a parenthesis or does it get a bracket? Well, open circle, that wrecks everything. So because there's an open circle here, 0's never included. So it gets a parenthesis. But 2 now, 2 is included here in the number line, in this line, but because it's also included as an endpoint here with a closed circle, because it's in both, it now gets included. Therefore, it gets a bracket and not a parenthesis. So that's why this answer differs a little bit from the previous example because of that closed circle. So because of this closed circle, it means it's included. So I have to include it in my answer. So that's how we do union and intersection problems with interval notation. And then finally, let's do our absolute value problems. So the first one, absolute value of 5. Well, remember from our property, whatever's inside just becomes positive. So it's +5, it stays +5. Number two, absolute value of -3. Well, again, whatever's inside becomes positive. So it's -3. The absolute value is +3. And then lastly, if I have 1 minus 4 over 4 minus 1. All right, I'm going to need to do a little bit of work first. So 1 minus 4 is -3 in the numerator. 4 minus 1 is +3. So -3 divided by +3 is -1. An absolute value of -1 is just +1. So the answer to that would be +1. And that's it for our examples for video 2 for lesson 1. These examples should be a good guide for you on the web assigned homework that you'll now go and tackle, hopefully. Yeah, so good luck with that, and we will see everybody in lesson 2.